Hello and welcome everyone to our February 25th Jupyter community call. It's the first community call of the year, and my name is Rosarius. I'm going to be your host today. Um, this is a place for contributors to connect with each other in the community, and so I want to give a special welcome to all the first-time attendees and returning attendees as well. Thank you. Um, Everyone who's presenting today, thank you. We're looking forward to hearing from you. If you find that you are inspired by any of the presentations you see and have some last minute items to add to the agenda, please feel welcome to add any Jupyter or OSS related items. This a reminder, this call is being recorded for the YouTube channel, the Jupyter YouTube channel. So we do follow the code of conduct, which you will find a link to right here in the notes. So we have a few people signed up to chat with us today, and we also have a short report section that we wanted to. We have enough time to kind of highlight these shortly, or briefly, I should say. So one of the first items here was one that I added on behalf of the Jupyter Community Building Working Group, or JCB for short. And this is an update on an upcoming change. So this is last year, Martha Cryan opened an issue, and we have it linked here at the end of this little snippet. This was to gather input from the community about a proposal to merge the JCB and the DI Standing Committee. It was a change that's most motivated by the limited membership of the DI committee, meaning Martha and myself, and we're both members of the JCB. And so after some community feedback and discussion in that issue, fellow JCB member Matt Fisher has opened up a PR to make that a formal change. So we'd like to welcome any feedback in that PR. Please take a look at that. And we also want to highlight that this is purely a structural reorganization, as DI responsibilities are still a core priority and ongoing commitment of the JCB. So that's it for that update. I think we have a Jupyter AI update. I'm not sure if someone on the call wants to give that a brief
Yeah.
shout out.
Hey, Rosio. Yeah, thank you. Thank you. Yeah, I want to share just a quick update here. So, long story short, we plan to release this by March 31st, 2026. Like, I know that we have promised previous release dates. This is absolutely positively going to be the final one. We have found a really promising new direction for Jupyter AI that involves agent client protocol. And the long and short of it is that it's going to support multiple AI agents inside of Jupyter Lab, like Claude Code, Codex, Gemini, OpenCode, Goose, Kiro, and any other crazy ones that you can name. If you're interested, feel free to leave a comment on the issue if you have questions, thoughts, concerns, etc. Um, I would love to give a demo, but I really need to get back this, and I didn't know the community call was today. Are we doing another one of these next month, by the way, Rosio?
So we can definitely talk about like the cadence a little bit more. We
Yeah,
will for sure have these at least quarterly.
okay.
So four times
Yeah,
a year for sure.
maybe.
I
Yeah,
think
maybe
maybe
after.
yeah.
Yeah, that's fine. That's fine for us. Yeah, we can give a demo after the official release. Yeah. So, but yeah, keep an eye on our progress, and yeah, we'll share more progress updates later. Yeah. Thank you, Rosie.
Thanks, David. Um, uh, I think we can go ahead and start with some of our agenda items. Um, so I will stop sharing my screen here, and I will hand it over to the first person that's up, and that is Martin Renaud.
Thank you. Hello. How long do I have actually?
We have a fairly short agenda, so I'd say maybe anywhere from 5 to 10 minutes would probably be good. Is that adequate? Or?
Well, I could fill half an hour if you give it to me, but I'll do my best to fit it in 10 minutes. Okay, so let's share my screen. And actually, I'll stop my camera because I will save some bandwidth. Okay, so hello everyone. Today I wanted to show you notebook links. So if you haven't heard of it, at Quantstack we released that new service called notebook.link that allows you to easily share notebooks online, and it's all based on Jupyter Lite, so it's a tool that easily scales, and it's super fast, you will see. It's super cool. I'm super excited about it. So I would like to show you tons of it, but I'll try to go as fast as possible and show as much as possible in a short time. So if you go to the website, you'll see that we have a gallery of examples that you can try. So if you click on any of them, you will actually get to a Jupyter Lite deployment that showcases some notebooks. So when you get to this, you have a Python kernel that loads, and you can start executing the code. And basically what NotebookLink does is that it will pull the packages on your machine, in your browser, to allow you to execute them entirely in your browser. So this is Jupyter Lite based. So Python actually runs in my browser page right now. It's not some complex server that does it. And this notebook that is really cool, it generates a maze and then it computes the shortest path and display it. So this is using, I don't know, NumPy, scikit-image, some IPy widgets, some IPy canvas. It's really cool. So this is one notebook link that was created, shared to the world publicly, and you can try it. I can try another one, like for example, the C++ one. This gets crazy really fast. You get interpreted C++ in your browser, in WASM, and that's actually super fast to execute C++ code. And this is really good for making teaching material and starting to learn C++. So this is some content that was shared. I'll show you quickly later how to build some content and share it. But I also wanted to show you briefly another killer feature of NotebookLink, which is to try GitHub repos quickly. For example, there's this IPy leaflet library that I would really want to try. I think it's really cool. You can try it with NotebookLink quite easily. You just change the URL to the notebook.link/github.com Jupyter widgets IPy leaflet. You press enter, and it doesn't work. So it doesn't work. Why? It doesn't work because IPy leaflet, the IPy leaflet repo actually has an environment.yaml file that defines the conda environment to use with IPy leaflet. And this one uses conda-forge and then all the dependencies it needs to run the notebooks. But it's using conda-forge only. And in Jupyter Lite, in WASM, we've been working on a new channel that you use on top on conda-forge, which is called mscript-forge. And that channel allows you to get packages that were compiled for WASM so that you can use them in your browser. So yeah, what it did, it tried fetching IPy leaflet, it sees the environment, doesn't work, I cannot find SciPy because the SciPy that is on CondaForge is not compiled for WASM, I cannot use it. That's fine, you can press continue with the default environment, which is basically just a simple environment with just a Python kernel. And then I can try executing the notebooks. And of course, it doesn't work because IPy leaflet is not installed. But that's also fine. So what I can do in NotebookLink, and actually it's also an open source feature. It's not specific to NotebookLink. It's with Jupyter Lite Xus. You can do pip install IPy leaflet, and it succeeded, but not quite yet, because some dependency cannot be installed from pip, because as you know, PyPI packages published there, they are either pure Python packages that you can run in WASM easily, or they are built, like they are compiled code that was built for Linux, for macOS, or for Windows. But this was not compiled for WASM, so I cannot install markup safe from PyPI because it was not compiled for WASM. So if I try to import ipleaflet, of course, no module named markup safe. But that's fine. Mamba install ipleaflet. No. Yeah, okay. I just wanted to install markup safe, but that works as well. So if I do this, you see that it changes ipleaflet to come from PyPI. Now it comes from CondaForge. And markup safe is pulled from mscript and Forge. And now let's try to import it. And it works. Ta-da! So this is, you see, it's really, really fast. I install the package and this is happening entirely in my browser. No server required. Actually, nothing is stored on the notebook link server for this. Like everything I do is local to my browser. And if you're familiar with Jupyter, you may feel surprised because ipleaflet actually ships a lab extension that shouldn't work as is without me refreshing or something like that. But it actually works. And Notebook Link actually is really aware of that environment we're using, the command environment we're using, and it can detect the lab extensions that are installed dynamically and load them dynamically. So it just works without having to refresh. And this is all cached. So if I refresh the page and try again so you see my edits were saved. And if I try again to import ipleaflet and create a map, it works, of course, because the changes in the environment are not transient. They are cached in your browser, and when you refresh, it just works again. And yeah, I said I would be quick, but I want to show so many cool stuff. I can do Mamba installed XUCPP. And before that, I only had Python available, but now I have C++ because I installed XUCPP dynamically. Now I can create a C++ kernel and start executing some C++ code. But yeah, let's not take the time to, you see the kernel started. I don't have time to demo this. Okay, so that was a demo using ipleaflet, which is not set to work with Notebook Link as is. The environment is not ready for that. I wanted to show ipycanvas quickly. So ipycanvas is another lab extension, another widget extension for Jupyter. This one was set up to work with Notebook Link by default. It has a .nblink folder. You can see it as the equivalent of the one for MyBinder, and it has an environment.yaml file in it that defines the environment that is ready to work for Notebook Link. So it has the mscript and Forge channel, the CondaForge channel, and then the packages I need to run the notebooks, and the kernel, of course. And I also have a log file. This is not mandatory for Notebook Link to work. If it doesn't have a log file, it will solve the environment on the fly when you get to the page. But you can provide a log file with all your packages pinned if you want to be sure that it works through time. So let's see, let's try. If I change the URL to be notebook.link/github ipycanvas, I can directly execute notebooks. And the packages are already installed. You can try it after that call if you want. So yeah, that's an easy and quick way to try Notebook Link, either from a GitHub repository or the examples that are showcased here. But now to the interesting part, you are a content creator, you want to create contents and from notebooks and then share it. This is exactly what Notebook Link is made for. So you get to the dashboard of Notebook Link, and when you have an account, you can then create new projects, create environments, and then create links to those projects to share them. So I can show quickly, but we have an environment creator that is fully in browser as well. I can edit the YAML file. It solves it. I can give my environment a name and save it for later, use it for my projects. That's great. Then you can create projects, select the environment you want to use, give it a nice icon, give it a name, save it, and then you'll go to the Jupyter Lite page to create your notebooks and edit your project like this. So this is really cool. Now, I created a project before joining the call so that I don't have to create content on the fly. This is the Lorentz equations notebook that you all know, I guess, from the tryjupyter.org. So I created an environment with all the dependencies needed to execute that notebook. Now I'm really proud of it. I want to share it. So what you do, you create a link for it. So from the link form, you go and say, okay, I want to create a link for my Lorentz project. Let's name it foo. For now, this is a private project that I'm not sharing to the world. But to share it to the world, you need to make what we call a public snapshot. So a public snapshot is a snapshot of the project at a given time. It will make that snapshot at the given time and then make it public, and it will be accessible to other people. So let's do it. And now I want the Lorentz.ipnb file to be opened by default. And this creates me that long link that I don't want to read. I can give it an alias, so just foo. And this would create notebook link /martin/foo. And I can open the Jupyter Lab interface by default, or I can go and open the notebook interface by default that we call single notebook interface here. But this is really just plain Jupyter Notebook, and it will open my notebook by default. Or you can go and select presentation mode. So let's submit it. Actually, you could see you can create links from projects or from GitHub repositories. So if you give it a GitHub repository, a commit reference or branch name, you can create a link that way as well. But yeah, let's try the presentation I created from my notebook. Yep, it creates a medium-like page. It's a bit slow because I'm sharing my screen. I'm doing a bit too much. And this is the demo effect. It's always work way less than it should during demo, but yeah, it executes the notebook. It makes a nice and shiny presentation out of it that you can share. And since I created the project from the notebook link dashboard, it's the environment is locked, everything is locked. If I never edit my link, it's always working. Packages cannot change under the hood. Okay, so that's how you create a link. Now we have more features in notebook links that I would like to show. We have add-ons, what we call add-ons. For now, we have only one, but there are more coming. We have the AI assistant add-on. So I have my Mistral key here that is set up, and I can create a project. Now let's use the default environment, and I want to enable the AI assistant add-on. Let's name my project bar. I don't care about the icon. So there I get Jupyter Lite AI installed. Oh, what am I doing? I don't want to annotate. Okay, I get Mistral with Jupyter Lite AI. So I can say, okay, please install scikit-learn and matplotlib. Then create a notebook that makes the hello world of linear regression, like the simplest example. Let's see how it goes. So you see it looks for available commands, then it will install scikit-learn in matplotlib. Oh, I even get the logs. It doesn't always do that. That's great. And then it creates a notebook, and I can try to execute it. So I was using the default environment, so I didn't have matplotlib and scikit-learn installed, but the AI was smart enough to install it with Mamba.js. Let's see if I'm lucky, because you're not always lucky with AIs. No, I'm not lucky this time. Yeah, the other examples it shown me before were nicer. Maybe I said simplest, and that was I shouldn't have done that. But yeah, it works-ish. As usual with AIs. So we have that. Maybe I can show also quickly. We have terminals, so you can have simple terminal commands with the drive. You can also like do Mamba install from the terminal. That's crazy. Mamba install XUCPP. That's it. I have the C++ kernel. I can use it. Everything is happening in my browser. That's mind-blowing to me. Yeah, that's what I wanted to show. And maybe last thing, and I guess I was super fast, so that's nice. There's this cool project we've been working on with starting with a grant from ESA and then with other projects, other people from CNES supporting it, and which is called Jupyter.js. So Jupyter.js is a way to edit JIS files in Jupyter, and it works in Jupyter Lite, of course, and it works in Notebook Link. So yeah, let's try it. I have this repository where I have some Jupyter.js examples. I can do as before, Notebook Link / GitHub. I have an environment file that was set up to use Encrypt and Forge, so I'm good. And it installed Jupyter.js Lite. So there I can create JIS files. Let's load the base layer, whichever. And it works. I can create layers, I can edit, load my data. I can do nice things like this. I have this example that is nice. So Jupyter.js has, okay, I clicked twice, I shouldn't have. This example has a story map. So a story map is a new Jupyter.js feature that allows you to tell a story around your data on your map. And the way it works is that you can see it as a sequence of slides that we call segments. Each slide has a markdown text, some image, and then some layer properties. So I can change the way I render the data on the map on each slide of the story. I can preview this story here from the Jupyter.js editor quickly. So as you can see, it has an image. I have some text. My laptop is suffering right now. But yeah, it makes animations, go to some parts of the UI of the map, and then changes the way the data is rendered to showcase some features of the data I want to show. So this is one really cool feature of Jupyter.js. And Notebook Link has a super nice way to render this, and I will show it to you right away. So let's create a link. Oh, thank you. Let's create a link from that repository. So it was this one. Oh, I have it saved. Great. Let's call it story. Try. I want the main branch. That's fine. And I want presentation mode. Oh, and content path, content story map.js. And let's give it an alias, story try. Okay, and because I selected presentation mode, Notebook Link will be smart enough to actually it's not Notebook Link, it's Jupyter.js, Jupyter.js in presentation mode is smart enough to detect that it is in presentation mode, and it will render the story map nicely. So let's click on it. This is a link you can try. I can copy paste in the chat later. And yeah, it works. So it renders it in full screen, shows you the story map in full screen, and I can drive it. And yeah, you can use the scroll wheel to scroll through the story. I think it's really cool. And that's it for me. We have more coming up to Notebook Link. Please stay tuned. And most of what I've shown today is actually open source. Notebook Link is built upon Jupyter Lite AI, Mamba.js, Jupyter Lite Goose kernels, Mscript and Forge, Prefix Dev, Conda Forge, many open source tools. Like the list is endless. This is Notebook Link is like I would say gathering all of those tools to build this amazing service. And yeah, thank you for listening. If you have questions, I'm happy to take them.
Maybe we can allot for about maybe 2-3 minutes for any questions. Not hearing anything yet, but if something comes up, maybe Martin, if you're sticking around, we can always come back to it towards the end of the call.
Sounds good. Thanks for it. Thanks for listening.
Thank you. That was great to see. I think okay, give 2 to 3 minutes of awkward silence. I cannot. I'm one of those that cannot like sit in awkward silence, so that's why I just feel it talking. But yeah, we will come back. Oh, sorry.
The last the person who used to host these calls when she passed it off to me, she was saying that the best thing to do is have a cup of tea and just sip your tea. And just don't think about the silence. I think that's a really good tip. Anyway, but you don't have to do that.
I wish I had tea but I have water, but I'll try that next time. Thanks, Martha. Great to see you as well. Didn't realize you. Up next, our next item on the agenda is by Darshan. So, if you'd like to take it away.
Yeah, thank you, Rusio. So, hello everyone, I'm Darshan Paudel. I'm a student and open source contributor at Jupyter Lab, and I'm working with open teams now. And I'm joining here from Nepal. It's my first time at a community call, and it's already almost midnight for me, so I'll try to be very quick. And okay, so in the first round of Jupyter community funded proposals, four of the proposals from OneSite PBC were selected, out of which I am involved in two of them. And these projects are still ongoing. One of them isn't even released yet, but I just wanted to share what we are working on this community call. So the first project that was selected for funding was improving code quality in Jupyter Lab, Notebook, and other extension code bases by developing custom linting rules. So I'll quickly share my screen and give a small demo on this. Mm, Okay, so this I've taken a code base of Jupyter Lab Favorites, which is a front-end extension under Jupyter Lab Contrib organization. I was working on this last time, so I took this. So if we have contributed to Jupyter Lab, Jupyter Notebook or any extensions, then we know that we follow a lot of Jupyter's and Lumino specific conventions. And sometimes it's very easy to mess things up like this. Like every front-end extension, we have a front-end plugin here. And and one convention is that the order of arguments in this activate function must exactly match the order of tokens provided in this requires and optional keys. So on reiterating over this function again and again, it's very easy to mess up things like suppose I missed and kept this main menu argument below toolbar registry. Now everything is fine. There's no red squiggly lines, and even the linting passes. So let me run ESLint check, and it doesn't catch any error. Even the build passes, and when the new contributors make these mistakes and push their code, this mistake is found out after sometimes 30 to 40 minutes of testing in Jupyter Lab, and we have seen these cases sometimes. So to solve this and many other problems like not providing descriptions in plugins, not providing description in those commands, and not providing translation wrappers to string that are displayed in user interface, we are developing a project called ESLint plugin Jupyter. So it's part of that community funded proposals, and within this we have developed some rules that are specific to Jupyter Lab code bases. So for example, let me quickly use this. So this package isn't published yet, but I've linked it locally in this project. So if I add a plugin, uh, ESLint plugin Jupyter, and then I add a rule saying Jupyter, it was plugin activation arcs, and set it to error. And now if I run this linting again, now yeah, it catches those two errors. So it says argument activation toolbar registry does not match the order of requires optional token. So, and I don't know why my editor didn't so, but it shows a red squiggly line over this function, and the contributors know at that time, so something is off, and they can correct it at that time. So we have many other cases like this, and we are actively developing rules to address them. And if you are a contributor or a maintainer and have faced this type of problem, and you think that there are other things that deserve to be here, then feel free to raise an issue here, uh, or in this drop a comment in this thread that we are discussing about this plugin. So this was the first project that we are working on, and there's another project that we're working on that is also funded by Jupyter CFP, that is Jupyter Builder. So uh, we are trying to separate the Jupyter Lab build system into a standalone package called Jupyter Builder. Now, if I go into this extension again, and if I show you the build dependency here, then we can see Jupyter Lab here. Now, building this extension requires the whole Jupyter Lab, because in Jupyter Lab codebase, we can see that the builder package is within this monorepo. So this is the JavaScript package which contains all the build scripts, and inside the Jupyter Lab package, we have other scripts that are used to build, like the Jupyter Lab package manager, and everything is here. So for building an extension, we need a whole Jupyter Lab, and this also creates a maintenance overhead. There are a lot of code within this, and it would be easy if we could separate this build tools into a separate package, that is Jupyter Builder. And we are actively working on this, and we have made it to a point where we do not require Jupyter Lab at all for building. So currently, if in package.json, if I see build, yeah, so it for building it uses Jupyter Lab extension build command. For this we require Jupyter Lab. And now if I change this from Jupyter Lab to Jupyter Builder build and run this command, now instead of Jupyter Lab, the Jupyter Builder comes in, and it successfully builds this project. So I have also raised a PR in extension template repository to replace Jupyter Lab with Jupyter Builder. And there are some issues we are facing, like how do we compare how do we verify the compatibility between this extension and the Jupyter Lab we have. For that, for temporary solution, we are extracting the data from GitHub for the current Jupyter Lab version, and then comparing it against the metadata of extension and verifying the compatibility. And we have also added a flag, which says core version, where like extension authors can give different core versions and build their extension against different Jupyter Lab versions. So yeah, this is also an ongoing project. And this ESLint plugin Jupyter that I talked about, this hasn't been released yet. It's still under my account. We hope this will soon be transferred to Jupyter Lab repos organization. And so, and this is Jupyter Builder. It has been released, but we are actively working on it, and we will soon be releasing more versions with more stable behavior. So yeah, this was a very short demo from my side. And if you are a contributor or want to provide any feedback, then I'm happy to take them. I cannot find Zoom. Oh. Thank you everyone for listening.
Thank you for sharing, Arjun. That was really cool to see. I'm sure it's going to be really helpful to a lot of contributors. I think we can give a short time for some questions if there are any.
We all decided to cheer for him silently.
Okay. Okay. I'm not hearing anything. So again, thank you, Darshan, for sharing with us. Looks like somebody, at least somebody's installing, Constantine's installing it right now. So good to see. Okay. We will go on to our next presenter. Is Prasoon.
Hi everyone. Can you hear me? Yes. So my name is Prasoon and I'm based in Hyderabad. So recently, like a year ago, I built this project called Jasper. So this is like a new implementation of Jupyter server in Go, and I'd like to share about it. Start sharing my screen. I'll have to rejoin once. Sorry.
Okay, we will give person maybe 30 a minute or so, and they can join us again and share his screen.
Not gonna lie, I wish the actual Jupyter server was written in Go, so I'm curious to see the
Looks like person's back.
I had to join because sharing was not enabled on my machine. So sharing again. Yeah, can you see my screen?
Yes, we are seeing your browser.
Okay, so this is how Jasper looks like when you load it. So it supports various kernels like Arduino kernel, Python, and R, Julia, Go, Ruby, etc. And this is, I'll show you an example about the performance. So this is a notebook that I opened. I select it. You can see that it has all the functionalities. I'll start running cells one by one. So its execution is really fast. And so I keep on running. Now I go to pandas. You can see that the responses are instantaneous. Now the kernel startup time is also really fast. So if I restart the cells, let's say here it's 30, I do a rerun. All the cells have executed again. So how do I do this is with the help of Go. Plus, if I go to the launcher, there's a terminal supported. And plus this file browser is like much more like VS Code or other code editors. Plus, we have version control, then Jupyter info, then settings. I can also switch it to a dark mode. Now coming to the performance. So this is a repo where I show that how it's better in performance. So what I do is I try, one sec, let me take you via the slides. So in terms of performance, CPU use, Jasper uses 500% less CPU, and in terms of RAM users, we use 4000% less RAM. And uh, in terms of architecture, when we have a Jupyter lab, we have a Jupyter server. And this, the backend is written in Tornado, which is a Python based. And then we have a React frontend in Lumino. Then we have zero MQ connections to the IPython kernels. Now, if we go to Jasper, there is not much change. The backend has been rewritten into Go backend in Gorilla, and the frontend is rewritten. It's not. It doesn't uses Lumino. So as a result, if I show you the RAM usage, so we always use less than 12.5 MBs of RAM. Like what I on the x-axis, you can see the number of kernels 0, 20, 40, 60, 80, 100. And in terms of CPU uses, this in Jupyter, it keeps on increasing. And at 64, you can see a few kernels crashing. And at 100, most of the kernels crash. But in Jasper, no kernels crash. So let's say if I send around 10 messages per kernel per second to all of these, I will keep receiving the 5x, like we will always have the, like, no messages will be lost. Now, in terms of RAM uses, uh, like for 0 to 100 kernels, you can see that the RAM is flatlined. We are always less than 44.6 MBs, but Jupyter Lab, it goes till 1143 MBs of RAM, and at this point, some kernels are even crashing. So how we do it? In Go, we are using uh, in Jasper, we are using Go, and with Go, you can use all the CPU cores available on your machine. But in Python, you're limited to just one core. Even the GIL limits you to not go beyond a single core. And what are the benefits? You get much a lightweight way to run your Jupyter notebooks and improved responsiveness. And for enterprises, it has much better cost efficiency and scalability. Now, one sec. So this entire, like, the benchmarks have been put in this repo. Like you can run on run this on your own machine. Plus, I have provided the exact methodology. So like how I do a benchmark is I try sending messages to the kernels, and I do it via Go routines. And this is in a very specific controlled environment, so that we make sure that both Jupyter Lab or Jasper, they have the same access to resources. And uh, so this is like two kernels, 10 RPS. You can see that the CPU usage is higher, and plus even in here, like the RAM usage is higher. Then the throughput, we have compared the throughput. Like in this case, two kernels, 10 RPS, both Jupyter and Jasper have the same throughput, like even the sent and received ones. Like for four kernels, like the throughput would be the same. For eight kernels, same. At 64, you can see the message sent are the same, but the throughput, Jupyter, the throughput starts to drop. And same in terms of 100 kernels, like you can see the throughput has totally dropped to zero, like the kernels have crashed here. So this is for an average summary comparison. Plus, like for 100 RPS, like per kernel, we can see that at 8 kernels, the throughput for Jupyter Lab starts to drop. And 16 kernels even more. And by 32 kernels, Jupyter crashes really badly. So, and 100 RPS. At the 64 kernels, you can see that even Jasper crashes and Jupyter Lab crashes. So this is because the messages that are on the ZMQ channel, now the rate determining step is the Python kernels. So they cannot respond back really fast. So that's why even all the ZMQ kernel connections are closed. So you can see both Jasper and Jupyter Lab both start to crash. So I have put in more detailed explanation like how the crash was and how what are the reasons. So like stream is closed. So yeah, that's all. And let me know if you have any questions.
Thank you, Prasan. I think there are some questions in the chat if you'd like to take a look.
So first question I had was, would it be possible, or have you ever tried running Jupyter Lab with Zasper as a replacement for Jupyter Server? So like mixing and matching?
Actually, by that, I could do this, but I think I have to I made some changes in the contract, the interaction contracts, but it can be done.
Okay. So are there any changes that we should make in the contract? And maybe let's take this offline and discuss that on Jupyter Server repo, like any changes to the protocol that we could make to make it easier for Zasper to be very performant. I would love to explore that. I also would love to explore potentially using Zasper with applications where the front end needs to stay as it is with Jupyter Lab, just to get this performance boost. I think that this is super interesting, something that I've been following for a while, and people I know were interested in looking whether we should rewrite Jupyter Server to a faster implementation.
Yeah, sure. I think it can be done. There are some content API. I have made a few changes. In content, you make a request via the query params, but in Jasper, you have to do it via the method body, and plus there are some other changes as well. But this can be done. Like not much. Like you can even put an adapter and then it can work.
Thank you.
Thanks. And also, I'd like to thank you all. It's like I use the Jupyter Wire protocol, and it was very informative, and that's how I was able to do it. Plus, I have not changed much of the contracts. Most of the things are from Jupyter specific itself, the REST APIs and other contracts. So I have not made much changes there.
I have a
And regarding
question.
extensions, not
Yeah.
all extensions are supported.
Mhm.
So I try to support them, but I have a full-time job somewhere else, so I could not focus on it. But you can make I added support for VND and Viga, so it can be done.
Okay, so do I need to write the extensions in Go language, which is Zapsper's use, in order for that to be run in Zapsper?
So no, I think you just have to right now the front end doesn't follow the Jupyter Labs protocol at all. So
Oh,
that's why
okay.
there is difficulty in connecting the dots. Plus, in terms of the backend, Go is just a broker, just like Jupyter server. The main execution happens in the Python kernel.
Oh,
So
okay.
you just have to write the front end in the right way so that you
Mm,
can make the extensions work.
okay, cool. Thank you.
Welcome.
Thank you, Prasan. I think given we have only about 5 minutes left, I will send it over to Mike.
Thank you. So I just wanted to quickly share an update from another community-funded proposal for Jupyter frontends, which is improving the visual regression testing that we use, and showing my screen right now. What this does is addresses a limitation that we had with pretty large test suite where the tests were slow to run, difficult to update, not reproducible. And just wanted to give a quick update showing that there is some progress being made. We managed to cut the average time from about 55 minutes to 14 for visual regression tests running for Jupyter Lab. Now, this has not propagated down to extensions yet, which use a different copy of this workflow and which not necessarily always need all of that. But this refactor also allowed us to change the workflow for taking visual regression snapshots and make it more secure, something which I hope I will be able to demo. So here I have a request which is updating all the colors of the borders to purple. Not a very interesting change itself. Of course, purple is the best color, especially for borders. So previously we would issue a would please update snapshots command. Now to distinguish that temporarily, I'm using a slightly different trigger. And because it's still in development, I need to actually go to the list of actions and approve it. Let's see. Okay, here it is. So I will approve that to run. And a job which previously took another 50 minutes, so another hour waiting on your PRs to get the new snapshots, now should take advantage of the assets that were already prepared in the 15 minutes run on CI. And within about a minute, we should get a pull request generated proposing to replace snapshots. So while this is running, next step here is to make sure that the snapshots are reproducible, and for that we will need to fix fonts and not depend on system fonts at all. Now for any extensions, front-end extensions, unfortunately this means that the next Galata update will require updates of snapshots. Of course, there will be a way to opt out of this, but I think it is highly recommended because across all operating systems and platforms, the fonts should now stay the same and there will be no longer need to update snapshots as we transition to new versions of operating systems. So let me see if we can finish this demo. Apologies for the background noise. Okay, this is taking longer than usual, so to not block the meeting because it's already at time, I will stop here.
Thank you, Mike. I think last up we have updates on importing notebook with import env, and
Oh, we're gonna keep going? Great.
If
Thank you. Um, cool. I have been sitting on a monster PR for a while from Nick. I don't know, has anybody else get PRs from Nick and they're just like, oh, this is gonna take some time to review here. But I reviewed it the other day and I stopped reviewing it because I found some of this stuff so remarkable here. So Import MB is a project that Deathbeds has had for an extremely long time. It's been used in some projects. And the general feelings about notebooks have kind of made it hard to put this out there a little bit more. It often will get a little bit of pushback, but we're hardening it up and it's got some cool features. So Nick has a pull request that's updating this. I'm going to merge it soon and then we'll drop a release. So hopefully before the next community call, this is actually a package. So I figure I'll share it now. And if anybody else wants to go and take a look at this and offer some comments and think about perhaps how it might be useful, that would be really great. So I'm going to go through and look at the read the docs, read the docs, read the docs, read the uh, mm, 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 162 somewhere. Where's the read the docs thing? I had it right up here. Sorry. Here it is. Okay. So this is the light build. Let's just go to the top level here. So here's our docs. There's not really much to it. Like we have this context manager. It plugs in the sys paths and then it makes it so that notebooks can be imported. It's not really all that much. It's just like hooked very deep into the Python import system. So we have demos in Jupyter and these were the things that kind of shocked me the other day. And I like to do them in Jupyter Lab, actually. Let's see. Open up in Jupyter Lab. I forget about the caching issues here. Come on, open up. Open. We'll get there, guys. Sorry. Okay, so let's go and do the widgets notebook. I like this one. So the widgets notebook just says that we have some widgets and we built them in a notebook somewhere. So now if we go back to the tree and we open up the plumbing, we find that there is the application being built in a notebook, full development space, like full hands-on, and then just at a high level, we get a fun little multiplication widget that Nick built. So these are just examples of how some of the Jupyter features can be used this way. This one, let's do the docs one. So this one's pretty cool because it talks about some extra notebook features that kind of like enforce better coding practices. So if we go and run this, we make a function. We describe the function before the function in a markdown cell. And then we make a class. And that class is also described ahead of, or that class has a doc string itself. But for some reason, Nick was like, it would be a great demo if I just built this in Sphinx. And then I showed the docs. And then we just got to look at everything right here in an HTML file. So it's doing a little bit of loading. I hope my okay, all right. Yeah. So here we go. We built Sphinx documentation of this notebook in the notebook. But one of the things that's fun is that the doc string of the function is actually the markdown like above it. Here. So this is just like a little feature when you're importing stuff for a little bit better documentation. And then the last, what was the other one that you have? Oh, test notebooks. This is crazy. This is wild to me. I think the implications of this are kind of strong, actually. So we're going to go and take a look at our PyProject Toml, which has some PyTest things in it. So we're going to do a test pass and we're going to do a test fail. And since we can import notebooks now, we can actually use notebooks as source for tests. So we can be developing our application, we can be developing our test, our presentation, all that stuff together. We can go and pass it through the PyTest HTML and get an interactive view of all of this. And then we can even go and we get coverage. I don't know. Oh, yeah, Nick added coverage in this. So now we're adding notebook coverage on top of the testing here. So we're getting a lot of features that make notebooks like super viable to be actually used as code. One of the things that we're missing is MyPy. Still trying to figure out how to like balance that line. Like so far, we've been able to rely on the consistency of Python's import system, but MyPy uses a totally different import system. So we have testing, we're close to types, we have documentation, we have all of the features of notebooks, but also this ability to go and consider them to mature as code. Maybe temporarily you use them as a notebook, but eventually you rip out the Python parts, the application parts here and the test parts there, and we can mature notebooks using this process. So if anybody wants to try it, I'm pretty sure what's on pip works right now, but we should have a new version dropping, and I hope that some of y'all or your users may find it useful. So, well, all right. So here's the trick. Inside of the code, if you look, it's a line for line JSON parser. So basically, it turns a notebook into what I call fuzzy code. So everywhere where we have no dependencies. You can run this with 0 dependencies. Has a standalone parser so that you get line numbers. So when we know we're in a code block, we just show the code. When we know we're in a markdown block, we make it a block string or a comment. So we get this really fluffy, spongy code. And like the goal is to eventually solidify it and compress it and turn it into the things that it's supposed to be. Thank you for letting me share.
Thank you for sharing, Tony. That was really awesome to see as well. And thank you everyone for staying on um, uh, and I know we're a little bit past, but if we have another minute or so, I think Mike was interested in sharing the output of the workflow that he read.
Okay, so here it is. So the PR got generated and included the snapshot updates. That's it from me. Thank you.
That was awesome.
Okay, thank you for that final update, Mike. That was really great to see. We are past the hour. Thanks everyone again for sticking around. Thanks everyone for sharing. Hope there's hope you keep an eye out. Sorry for the next community call and for the people that may have missed that are interested. I know there were some Jupyter Hub folks that were having a different event, so we'll try to keep an eye out for schedule conflicts like that in the future. But yes, thanks everyone again for being here. I'll go ahead and stop the recording.